Okay, so 12.4 is where we're moving, and it is simply called derivatives. Okay, so I'm going to split this section up into, well, almost the entire week. Okay, so we're going to start with the basic rule, and then I'm going to show you other rules later. Yes? Okay, we'll talk about it later. Sound good? Okay, so the basic rule. Given our function, let's just happen to say it is x to the nth power. Its derivative, which by the way, that's the notation for derivative, is the n, the exponent gets put into the front, and then x, and then you lose 1 in the exponent. So we're going to say n minus 1. Okay, so that's the definition of the basic rule of derivatives. Okay, so I'm just going to do some examples until I feel like you guys have this, and then I'll give you the assignment. Okay? So let's say, that's good, thanks. We have x cubed plus 4x squared minus 5x plus 8. Okay, so right now I have a fairly complicated polynomial, okay, with 4 terms. All I'm going to do is derive each term individually.
So you get 3x squared, 3x
okay, hold on. Okay, so if I'm starting with x cubed, okay, I start by putting the exponent into the front. So I would have 3. And then what's my new exponent? Minus 1, so it becomes 2. Okay, so that's the first term. Okay, what about the second term? What if I have an already existing 4 in front of it? You multiply. Okay, so 4 times 2 is 8. It's just a little apostrophe.
8x.
8x. Derivative.
Minus.
Okay, everybody good on the second term?
5x.
Okay, now if I have 5x, x is to what invisible power?
1.
1. Okay, so remember that this is to the first power. So 1 times 5 is 5. And if I lose 1 in the exponent, now it's x to the what? 0. What's anything to the 0 power? 1. Okay, so the idea is that I'm losing one of the x's. Okay, so that x goes away. What is the derivative of 8? A constant.
-1.
0. Okay, the derivative of any constant is 0. If you need to write that somewhere in your notes, go ahead and do that. The derivative of any constant is 0. Okay, so that is the derivative. You guys think that's a little bit easier than doing the difference quotient? Just a little bit.
I don't understand what, that's the answer?
That's the answer, yeah.
That's how you just derive it. What does that do?
Okay, so a derivative finds the slope at any given point. Okay, so they will ask you, they'll say, well, what's the derivative when x is 2?
That's not.
Right, but I will give you the x value. I'll say, well, when x is 2, what's the slope? So you would take 2, and you'd plug that in, and it would come out with the slope at that exact spot.
Did you come up with the slope?
So you're given a slope. That gives you the slope. Derivatives gives you the slope at any spot. Okay, let's try a harder one. You guys ready? Number 2.
Yes. How do you know if it's a constant?
It doesn't have a variable. Let's see. Let's try this one. 3/4 x squared minus 1 over x plus 4 over x squared. Okay? So what do you notice about this particular example that's different than the one before? It's got fractions, and specifically, not only fractions, but the one that's important is when the variable, Stokey, when the variable is in the denominator. Okay, we cannot make or find the derivative if the variable is in the denominator. So the first thing that I have to do is I have to rewrite this. Okay? So, to rewrite this, it becomes 3/4 x squared. That one doesn't change. But if I have 1 over x, how do I take the x out of the denominator? No, that's in solving. Okay, so remember that this is x to the first power. All you have to do is make the exponent negative. Okay, so this would just be x to the -1. Okay, and how would I rewrite 4 over x squared? 4x to the -2. Perfect. Okay, so that's the rewrite. Now I have to derive this. Okay, so the first term I have 3/4 x squared. So what's 3/4 times 2? No. 6/4, which reduces to 3/2. Okay, so remember when you have a fraction multiplied by a number, you would just multiply the top number by that value. What's my x2? What exponent? To the first power, so I don't have to say it. Okay, what's my second term going to be? Uh-huh. No, just a second term. Just a second term. Okay, so it turns into plus, right? Because I have minus, and then I have times -1. So that turns into plus x. What's my negative, or my exponent? -2. Good, because -1 minus 1 is -2. And what's my last term going to be? 5 minus 8. Good. X to the -3. Okay, now can I leave it like this? No, remember you cannot ever leave a negative exponent. So all I'm going to do is take those x's that have negative exponents and write them in the denominator. So this is going to be 3/2 x plus, how would I rewrite x to the -2 as a fraction? What's the number that stays in the top? 1. So 1 over x squared. And then minus, how do I write the third one?
8 over x
cubed. Perfect. And that is the derivative.
Why is that?
Okay, so do I need to do any examples where they ask you specifically what is the slope at a given point?
Yeah.
Like, so if I take this and say, find the slope when x equals, let's make it easy, 1. What would you do if they give you an x value?
Plug it in.
You plug it in, okay? So you find the derivative, and then you plug that x value in. Okay, so I can write the notation as the derivative of 1 is 3/2 times 1 plus 1 over 1 squared minus 8 over 1 cubed. Okay, so that would give me 3/2 plus 1 minus 1. No, I mean 8 divide. So it's 3/2 plus 1.
So is finding the derivative of something, is that just like normalizing?
What?
So like finding the derivative of a function, is that just like normalizing the
No. No, it's taking the function and being able to find the slope at any given point.
function? Okay.
Okay, so the slope, the function that's given originally is generally like, it's not a straight line. Okay, so like a parabola, or could be something totally crazy. Okay, and so the idea is I want to be able to find instantaneous rates of change. Okay, so then I know the x value can find an instantaneous rate of change. So what do we get? 5/2 minus 16/2, -11/2. So that would be the slope specifically when x is 1. So we find this pretty easy? Okay, so the second half of this is being able to find a critical point, or critical points. Okay, this is actually really cool, I think. Okay, a critical point is either a maximum or a minimum. Max or a minimum. Okay, so think about this. Let's say, for example, I just had a parabola. Okay, and I said, okay, if I'm talking about, well, this would have a minimum, right? Down here at the very bottom of this. Okay, what would be the slope at the very minimum of that parabola? Well, what would be the slope of it? What's the slope of a horizontal line? 0. Okay, so the idea of this is that the slope at a maximum or a minimum is 0. Okay, so this is really cool, I think. If they ask you to find a critical point or a minimum max of a function, so let's say they give us some, like, let's just do a parabola. Let's do 3x squared plus 5x minus 4. Okay, you can find the vertex of this using algebra, which we've done way back in the first quarter, or you can find the vertex of this by using calculus. Okay, so all I have to do is find the derivative of this. Okay, so let's do that real quick. What's the derivative of this?
6x.
Yep, and then plus 5. Okay, so 6x plus 5 gives me the derivative at any spot. If I'm trying to figure out what the x value is when the slope is 0, all I have to do is take the derivative and set it equal to 0. Okay, so the vertex, subtract 5, would be divided by 6, yeah, when the x value is negative 5, 6. That's kind of cool, right? Exactly, if you're trying to find the point. Okay. Okay, so they're going to ask you to find a critical point. All you have to do is list the x value of that min or max. Okay, and once we get a little bit further in this, I'll be able to show you which one is a min or max. Okay, we'll go through that a little bit later, but right now I just want you to decide where the min or max is. Okay? So that's it for today. So 772, and you have 2 through 24 evens for your assignment. Due tomorrow at the beginning of class.